Okay, for section 10.4, we are going to talk about vectors. If you've been in a physics class, you have probably talked about vectors before. If not, no big deal. We're going to kind of start at the beginning. So, first things first, I love a good definition. So, for topic one, we're just going to introduce the idea of vectors. Like, what are vectors? Okay, well, a vector is represented by a directed line segment. What in the heck does that mean? Well, it's a quantity that has both direction and magnitude. Okay, so well, what does that mean? Okay, well, magnitude, direction we can understand. Which way are we heading? Okay, but magnitude we need to understand a little more deeply. Okay, so for us, just kind of a basic definition of magnitude is that it's some numerical value, or we could say it's the size of some kind of a quantity. Okay. When you're in a physics class, a lot of times you will talk about magnitude like as a speed. So when you're talking about velocity, velocity is how fast you're going and in what direction. So when we're talking about velocity, the magnitude of velocity is speed. Okay. So we'll look at this really gently for now, but essentially for us at this point in math, magnitude is the length of the vector. Okay. So magnitude is just a numerical value or the size of a quantity. For us, it is quite literally the length of our vector. And then the direction is which direction is this thing heading or pointing? Okay. So in this image below, we have the vector PQ. You do need to understand the notation. So the notation, you usually name a vector by a letter of the alphabet, or in some cases like this, you have 2 points. So you have kind of the initial point, like where is this vector starting? And then you have the terminal point, where is this vector ending? So in this case, they have named this vector PQ, but the way we denote to our reader that, hey, this is a vector is you do a little line with like a hook on it, kind of. It's not really an arrow, because if we put an arrow, that's sort of the symbol for a ray. We want just, do you see what this did? We just want a little line with kind of like half an arrow on it. Okay. So we will indicate that we have a vector like this. Now, a lot of times we'll use letters like V. Okay. So we could have like a little V with this little line over it, or I think in a minute I show you this. You can also use like bold print letters. For me, I can't like write a bold print letter when I'm doing this with my like little pen. So I'll use this notation with like the little hat on top of my letter. Okay. So a vector has to have magnitude, which is length, and it has to have direction. Those are the two things we need to know. Okay. Now, whoa, what did I just do? Moving right along, we have here that vectors can really start anywhere. They don't have to necessarily start in a specific spot. They will have an initial point and they'll have a terminal point, but they don't like have to start anywhere. We will eventually talk about something called a position vector, which we kind of force a vector to start at the origin, but generally speaking, they can really be anywhere in the XY plane, okay? So it doesn't have to start at any specific point, okay? The vectors below are all equal, okay? Meaning they are all going in the exact same direction and they have the same length, okay? How do we know this to be true? Well, I can kind of show you here if you'd like to see, okay? So what we can do is we can indicate our horizontal and our vertical motion. Like how are these things technically moving, okay? Let me get this here. There we go. Okay, so looking at this first vector, which we're going to call PQ, and we'll put the little hat over it to say, hey, this is PQ, okay? We are going from P to get to Q. We would have to go to the right one, two, three, four, and then we have to go up one, two, three. So we go to the right four, and then up three. Okay. Now looking at vector RS, so I'm going to indicate that that's vector RS. I'll put that little hat on top of it. To go from point R to point S, so R being the initial point, S being the terminal point, we would go to the right one, two, three, four, and then up one, two, three. So four, comma, three. Now we have the vector TU. Okay, my initial point is T, my terminal point is U. And to get from point T to point U, I go to the left or to the right, one, two, three, four, and I go up one, two, three. So I go to the right four and up three. So then the question is, do they all have the same magnitude? Do they all have the same length? Well, of course they do, because we essentially have created these little right triangles, and these little right triangles have the same two legs. So therefore, that little hypotenuse, which really represents the magnitude here, they're all going to be the same, and they're all pointing in the same direction. If we were to line them up side by side, they would be basically parallel to each other. Okay. Now, the notation for the vector, I mentioned this like barely 2 seconds earlier. You can use this bold print letter. So a lot of times we'll think V for vector. You can use other letters though. You're going to see U in this worksheet. You're going to see W's in this worksheet. But V is kind of like sort of standard idea for a vector. So you can use this bold print lowercase v. Okay, a lot of times W as well. It's just for me, I can't like write bold print. So like I could say, hey y'all, this is not bold print, but this is bold print. And yeah, you can kind of tell that one's a little darker than the other, but it's not super, super obvious. So for me in class and in these videos, I'm going to use this notation with like the little hat thing on top, okay? So you can use either notation, be familiar with both in different books, different online homeworks, different websites. You may see the bold print letter, you may see the letter with the little hat. They mean the same thing, okay? So again, I will generally use this because I can't like print a bold letter, obviously, okay? Now, let's play around with this idea of, whoa, I keep like pulling up this other screen. So let's play around with this idea of vectors. So the thing is, you have to have length, you have to have direction, okay? I could go to you all and I could be like, hey, guess what? I drove 45 today. Drove 45 what? Yeah, 45 miles an hour. Okay, where? If I don't tell you the direction I was heading, that 45 miles an hour is meaningless. It's just magnitude with no direction, okay? I could say, yeah, man, the wind was really blowing. And you could be like, cool. Where was it going? Man, it was blowing 12 miles an hour. I don't know if that's fast or not. Let's say 40 miles an hour. That's much more dramatic. That wind was blowing, let's do 20. 40 sounds ridiculous. That wind was blowing 20 miles an hour, and you can be like, cool, where? Until I tell you the direction the wind was blowing, it's kind of meaningless, okay? So in order to have a vector, you have to have both direction and length, okay? So imagine that you're going to use this idea of vectors to draw the different scenarios we have here. Okay, so starting at the origin, okay, it says imagine walking 5 blocks east and then 3 blocks north. So we can kind of treat this XY plane as the north, south, east, west. This would be north, south, east, west. So we're going to start at the origin and it says imagine you walk 5 blocks east. So 1, 2, 3, 4, 5. Well, walking 5 blocks east, we can create a vector to represent that, okay? And then we turned and we walked 1, 2, 3 blocks north. We can use a different vector to represent that. And at some point in just a bit, we're going to talk about adding vectors, and we would basically do something very similar to this, and then we get some resultant vector. We'll talk about that when the time comes, okay? Now, for this part B, let's say we're starting somewhere else. Let's say we start at the spot 4, 5. So we're going to start at this just regular old ordered pair. So 1, 2, 3, 4, 1, 2, 3, 4, 5. This is going to be my initial point. This time I'm going to walk south 10 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my initial point. And then my terminal point is right here. And then from there, I decide to walk 8 blocks west. So I could go 1, 2, 3, 4, 5, 6, 7, 8. So my initial point would be the terminal point of my first vector. And then my terminal point of my second vector would be right here. Okay, so that's kind of how vectors work. You have to have a length, okay, and then you have to have a direction, okay. Now, I think we've got one more thing for this video. Yeah. Okay, so we have this idea, and we're going to talk a bit more about it later, but we have this idea of a scalar. Okay, so a scalar is just a quantity. Okay, so it's just some number. Okay, so a scalar is just a number, and I'm going to put this extra little bit here. It's just a number without direction. Okay, so I have this little, is it this or is it that? So for example 2, it says, is it a scalar? which means it only has magnitude. So it's just a number without a direction. Or is it a vector, which means it has magnitude and direction. So it's a number and it also has direction. So for part A, we have that the wind speed was 10 miles per hour. Now, a lot of times we have to acknowledge that yes, we're in a math class, but a lot of the sciences also have math in them. So please note here, speed is the magnitude. So I'm kind of giving away the whole thing here right now, but speed is the magnitude of velocity. So velocity is basically a speed with a direction. If you just have a speed, that's kind of like the magnitude of velocity. It's missing the direction, okay? So is it a scalar? Is it just magnitude? Is it just a quantity with no direction? Or is it a vector where it's a quantity that has, obviously magnitude and then some direction? So for part A, we have the wind speed was 10 miles per hour. Cool. Where was it heading? Which direction? We have absolutely no direction here. So in this case, we're dealing with just a scalar. And just always remember speed, it kind of flips people out because when we talk about just like kind of vectors in a very generic sense, we're talking about the length of the vector. So sometimes when we talk about speed, we're like, wait, that's not really a length. It's how fast you're going. Yes, it's how fast you're going over time in a particular direction if you're talking velocity. So just remember that speed is the magnitude of velocity, and that'll kind of help you here. So if we're talking about just a wind speed without direction, we're talking about a scalar. Now for part B, the wind speed was 10 miles per hour moving north. So now we have the magnitude and we have the direction. So this would be a vector. Okay? Now for part, oh shoot, I have part B twice. So this should actually be part C. This should actually be part D. Forgive me for my horrible typo. But for part C, we have that a car traveled 40 miles per hour. Okay, it traveled 40 miles per hour. Where? Was it going straight up and down? Was it going left? Was it going right? Was it going backwards? Was it going forward? Where was it going? If it was just traveling 40 miles per hour with no direction, it's just a scalar. Because remember, speed is the magnitude of velocity. So if we just have a magnitude, that's a scalar, okay? Now, part D, we have a car traveled 40 miles per hour at south 30 degrees west, which means we were traveling 30 degrees west of south, okay? So this case, we have the magnitude and we have the direction. This would be a vector. Okay, so please understand the difference between just a scalar and a vector. A scalar is just a magnitude, it has no direction. A vector has magnitude and direction. And then just remember, because this is going to come up from time to time, when you're dealing with speed, we're used to thinking of, when we talk about our vectors in this class, without an application problem, we're just kind of talking about them generically. Magnitude is a length, but just remember that speed is the magnitude of velocity. Okay, in the next video, we will add vectors.